Thank you. It is great to be back on this unseasonably warm evening, and I'm delighted to see all of you here. And we're going to have fun tonight. If you've been to our previous events in this series on the nature of reality, you have heard how difficult it is to pin down what exactly we mean by this word, reality, because when you start to peel away the layers of what we think is real, you will find a lot of misconceptions, and it gets pretty weird. Well, this evening it's going to get even weirder because we are about to dive into the human mind and how we perceive the world, and that is a strange place, let me tell you. There are all kinds of questions that continue to swirl around debates over the nature of consciousness. Can we ever bridge the explanatory gap between the physical stuff of our brains and our immaterial minds? Can evolutionary theory explain the origins of consciousness? And what about quantum physics? Does that have anything to tell us about how our minds work? All these questions are still up for grabs. We don't really know where consciousness comes from, but we rely on our conscious experience to navigate our surroundings, to give us some sense of what's out there in the real world. After all, this is our window onto reality. But what if all of that is wrong? What if our brain's picture of the world is actually nothing like reality, and external reality itself is a kind of fiction? Or what if we're hearing and seeing things that we know cannot possibly exist in the world? It all seems to be in our head, but we can't figure out why we're having these experiences or whether there's even an identifiable part of the brain that's generating these perceptions. So these are really challenging and counterintuitive ideas which cut against the grain of what we assume is real. So buckle your seatbelts, because I think we're in for a wild ride here. And we have two fascinating people to help us make sense of it all. Let me introduce them. Donald Hoffman is a professor in the Department of Cognitive Sciences at the University of California, Irvine, with joint appointments in the departments of philosophy, logic, and philosophy of science, and the School of Computer Science. He's the author of Visual Intelligence, How We Create What We See, which presents the modern science of visual perception to a general audience. He's the co-author of Observer Mechanics, a formal theory of perception, which offers a theory of consciousness and its relationship to physics. His current work seeks to explain how our perceptions have evolved to hide reality from us. Suzanne O'Sullivan has been a consultant in neurology since 2004, first working at the Royal London Hospital, and now as a consultant in clinical neurophysiology and neurology at the National Hospital for Neurology and Neurosurgery. Her focus is on epilepsy and helping people who suffer from functional neurological disorders. She's the author of two books, It's All in Your Head, True Stories of Imaginary Illness, about patients whose symptoms had psychological origins, and Brainstorm, detective stories from the world of neurology, about symptoms that are so strange, even doctors struggle to know how to solve them. Welcome, both of you.
Thank you.
So, Don, let me start with you. How accurately do you think our perceptions of the world reflect what's real?
Not at all. So they're shaped by natural selection to keep us alive, and they do that very well for a few decades. And it turns out when you look at what's needed to stay alive in our perceptions, truth isn't part of it. And you can actually look at the structure of evolution through tools like evolutionary game theory and ask specific technical questions. Do organisms that see reality as it is have a greater chance of survival, greater fitness than those that do not see reality as it is? And it turns out that organisms that see reality as it is are never more fit than organisms of equal complexity that see none of reality and are just tuned to the relative fitness payoffs.
Okay, you're going to have to give an example of this. So what is one organism, maybe us, that
Right.
just really does not see how things really are?
Well, one example I like to give is the jewel beetle. It's a beetle in Western Australia, in the outback of Western Australia. It's dimpled, glossy, and brown. The males fly, the females are flightless. And the males fly around, of course, looking for a female. And when he finds one, he alights and mates. And it turns out that in the outback, there are also these beer bottles that are dimpled, glossy, and brown that get tossed out into the outback. And it turns out that they're just the right shade of brown, that the male jewel beetles flock all over these bottles and try to mate with them. And the females are of no interest compared to these bottles, and the species almost went extinct. And it's the classic thing of the male leaving the female for the bottle. It's tragic, tragic, very tragic. But here's a species where the males had found females successfully for who knows how many hundreds of thousands of years, and you would think that means that they had evolved to truly know what is a female and what's not. And what we see is that's not the case. They evolved with a simple heuristic, a little trick. A female is anything that's dimpled, glossy, and brown, and apparently the bigger the better. That's what evolution does. It does things on the cheap, right? Because every calorie you spend on perception is a calorie. You have to go out, kill something, and eat it to get that calorie. And that's dangerous. So there are selection pressures to do things cheaply, and yet just enough complexity to get what you need to do, like mating. And so that's the kind of thing we see in evolution is we get what are called satisficing solutions. You get just enough to stay alive, and it turns out that truth isn't needed to stay alive.
Okay, so Suzanne, let me turn to you. You come at these questions from a very different perspective from your clinical experience in the world of neurology. Do we, from a neurological perspective, do we have a sense of, what's real out there?
I think from a neurological perspective that we trust this thing way too much is my perspective, and I would very much agree with what I've just heard. And I would even go further to say that when you hear a story about a beetle, we think, oh, well, we're a bit more sophisticated than a beetle. So I would hope that I would make a more logical choice faced with that decision. But actually, it isn't about intelligence. Our perception is constantly tricking us, irrespective of how intelligent or how perceptive we believe ourselves to be or how much we're paying attention. I mean, where I come from on this subject is I'm a neurologist. So I qualified with the expectation that I would look after people with brain diseases. So epilepsy in particular, but anything like multiple sclerosis, Parkinson's disease, these sort of disorders. When I took my first consultant job, which is our sort of most senior job, running your own service, for the first time in 2004, I was running a unit where I was investigating people who had seizures. We admit people to hospital. We video them while they're wearing EEG electrodes that measures their brain waves, and we wait for them to have seizures so that we can explain those seizures to them. And these were all people who were having very, very frequent seizures, the worst possible cases. And at the end of my first year in this job, 70% of the people I saw who were having convulsions and were unconscious were not unconscious according to our tests. So these people were having something that neurologists now call dissociative seizures, what in the recent past would have been called non-epileptic seizures, and 100 years ago would have been called hysterical seizures or hysteria. So these were people who appeared to be convulsing and unconscious, but the test said that they were conscious, and this was entirely psychologically driven.
Wait, so I'm just trying to understand this. So they, from their perspective, they were unconscious, but if you actually measure this using the tools of medicine, they were not unconscious.
So if you measure our brain waves, they're constantly changing, and they have a particular pattern during alertness. The pattern is changing if your eyes are closed, if they're open, if you're drowsy, if you're hungry. These people experienced themselves as being unconscious, behaved as if they were unconscious. But if you measure the brain waves, it shows a normal waking pattern, the sort of pattern you would see in someone who was wide awake and paying attention to you. And that is only part of the tricks that the brains can play on us, leading to illness. So now I see a lot of people who have problems like paralysis, blindness, memory impairment, etc., which are tricks of perception or belief. In fact, all the pathways in their nervous system are intact and could function, except through some trick of their own belief about their ability to function, they're unable to do so. So I would say that sort of beetle is the beginning of it, and I often think that people think, well, it wouldn't happen to me because, I'm intelligent, I'm paying attention, and I know what's happening in there. Sadly, it doesn't matter how intelligent you are, I'm afraid.
So I came across a quote from the poet Emily Dickinson, who wrote, "The brain is wider than the sky and deeper than the sea." Did she get it right? I mean, is the brain ultimately unfathomable?
Well, it's not ultimately unfathomable. It's unfathomable, I believe, in our lifetimes. Nothing is unfathomable forever. But I think what a lot of people don't realize is the degree to which we are in the infancy of understanding it. You know, when I qualified in medicine in 1991, we only were just beginning to get MRI scanners into hospitals. Now, you've got to think about that. That means that, you know, before the 1980s, we'd only seen cloudy pictures of the inside of this thing. We didn't even have any really good, reliable way of saying what bit of our brain did what. We relied upon injuries. So you injure the brain, you can't move that arm. Well, that bit of brain must move that arm. And that's how blunt our understanding of the brain was. And that was, you know, in the very recent past. So I believe that everything must be fathomable, but I don't believe we're even close. On the other hand, I don't consider myself a scientist. I consider myself a doctor who sort of, is... I practice an art based on a science. Perhaps you feel closer to the answers, Donald? I'm not sure.
Well, we're working hard on it. The cortex of the brain has about 86 billion neurons. Until a few years ago, I would have said 100 billion. So we're even learning how many neurons there are recently. And there are trillions of synapses connecting all of these. So it's really, really complicated. But even when we have a complete wiring diagram of some very simple organisms and know all the neurons and all the connections between them, we still don't understand what the system is doing. So if we're having trouble with a few dozens or hundreds, trillions is going to be very, very hard. And so we have to take a systems kind of approach and try to ask what problems is the brain trying to solve, and can we try to reverse engineer how they might be being solved, and then we can go back and look at the brain connections and see, is that what these brain connections are trying to do? Sometimes we'll use deep learning kinds of algorithms and say, well, if maybe the brain is using something like a deep learning kind of algorithm to recognize objects. If that's the case, can we go back and show how these neurons would all fire? So we're going at it from all these different angles. So it's a very rich field. I have great optimism that we will learn a lot about how the brain is wired and what it's computing. So, and there's great job security ahead as well.
Yeah.
So when you say, you're both saying basically brain science is in its infancy still.
Absolutely.
So I'm going to ask you to kind of look into your crystal ball a little bit. 50 years from now, 100 years from now, what's your guess as to how much further along will we be in understanding how the brain works?
I'm not sure I know how much further we will be along. I like to continue to be depressing about how little progress we've made before I can get that far, which is sort of, what we're, in neurology, we still cannot make brains better. We're still at the point of trying to figure out which bit does what. We're way better at that than we were when I was in medical school. But that's still the level that we're at. And we're still at the point where we're trying to stop people from injuring their brains and protect brain, because the minute you lose something, we have no way of getting it back. Either the brain heals itself, or we compensate in some way, or we don't get better. So I think where we really are desperate for improvement is in treatments, whereas we're still at the level of just trying to understand the fundamentals of the thing. So I think 50 years, I'm not terribly hopeful.
Wow, that's
sorry
kind of
to depress you. It's okay.
Don?
The planet might be dead then, so sorry.
That's even more depressing. I guess I'm a bit more optimistic. I think that we've made some breakthroughs in understanding that I didn't expect. So, for example, I didn't expect us to be able to solve the problem computationally about how to do object recognition for real three-dimensional objects. I thought that was so hard a problem that we would be several decades down the road. And it turns out with some of the new deep learning techniques, we're able to get computers to do that. And by reverse engineering those computer systems, we can start to get new ideas about how the brain might be doing this. And so my guess is that each new advance that we make gives us exponentially more power as we go forward. We're in the low part of this exponential curve. We're really slow and plodding. But I think each new step gives us more tools that we can leverage. So I'm actually quite optimistic, but my guess is that there are some very important concepts that we simply just don't have yet. So there's
But-
going to be some new discoveries.
So I'm interested in what you said. I mean, using these computer models to understand how the brain works. I mean, that's not obvious. I mean, I guess maybe I would have thought it's neuroscience. You know, neuroscientists who are going in there trying to figure out what's happening at a cellular level, you know, mapping, you know, what happens when this particular neurotransmitter is acting. You're saying that's not enough. You have to map it out with the computer.
That's right, and that's one place where, for example, artificial intelligence and computer science are working together with the neuroscientists to try to help reverse engineer what the brain is doing. So we view it like a reverse engineering problem. We got this black box, and we're trying to figure out how it works. And so we know in the case of vision that, you know, there's an image coming in at the retina of the eye. You have about 120 million photoreceptors. And then by the time you get to some higher level areas in the temporal lobe, we know that you're able to recognize faces and so forth. And so we know the inputs, we know the outputs of the system, so we can try to reverse engineer how could a system do that? What would you have to do? And so you can take it as a pure computational problem, and the deep learning techniques are the latest kind of technique. And I'm not saying it's the end-all and be-all, but it's where we are right now. And by looking at those, we can then go back and see how the different quote-unquote artificial neurons in the neural network might map onto the neurons in the brain and make maps that way. So we're like detectives. We're taking all the clues we can and working on it. So, and who knows, we still may be thinking about it in all the wrong ways, but the tools are getting more powerful. So I'm hopeful, but you may be right.
No, I mean, correct me if I'm wrong, but I was reading about an experiment where you ask someone to watch a movie or something over and over again, and then you can reverse engineer that so that you can, through some fMRI measurement, see what movie they were watching.
Exactly.
Essentially.
That's right.
But and I do find that very interesting. But isn't that can you extrapolate from one person to lots of people in that in a scenario like that? Because that's what we've been doing for years, is looking at individual people's brains and injuries, and then drawing conclusions from them. Is that going to be different?
It will probably be different from person to person, even between identical twins. We know that the wiring of the brain is different even between identical twins. But the question will be how much are the little differences important? So when you, for example, again, I'm not saying deep learning is the final answer here, but that's where we are, so I'll use that. When you train up the network, the exact pattern of connections between the neurons is probably, or the artificial neurons, is probably not critical. If you train the artificial net again, you might get a slightly different pattern of connections, but it would still have the same functional ability. So we're going to have to figure out what part of the connectivity is really critical and what part of it is slop. And so we have a lot of work to do there, but the individual differences may be important, but in other cases they may not be.
So I want to step back for a moment and just sort of try to wrap my head around this notion that what we think is real is not real. I mean, it's sort of, we have almost a fictional representation of reality out there. Why? I mean, wouldn't it be to our advantage to, have an accurate perception of the world? I mean, wouldn't that help us survive?
I'm going to give my very simplistic view of this before Donald gives the technical scientific view. I mean, the way we think about it as neurologists, it's practical. So I as I say, I think about things in a more practical way because I have to solve them practically for an actual person. And the way we think about how we perceive things is that we just can't handle all this information that we have. That it's just, it's too much. We'd be bombarded with visual and other sensory information all the time. So what we have to do really is just have some sort of a way of narrowing that down to pay attention to the thing that will stop us falling down the stairs, or the thing that will allow us to learn what we need to learn. And that is why we're constantly filtering out things like sensations. You're not feeling the chair underneath you now because it's not important for you to feel the chair. But the minute you start thinking about it, well, now you're feeling it. And that these, if you were constantly aware of everything that was happening around you, you wouldn't really be able to function. You need to shut down something. From my perspective, for my patients, that's something that can lead to really big problems sometimes. I meet people who are blind, although they have the capacity to see, they can't see. We don't fully understand how that happens, but we wonder if it is a sort of malfunctioning of this ordinary filtering system which we need in order to function on a day-to-day level.
I think what evolution has done for us is trying to keep us alive. And if seeing the truth was critical to keeping us alive, it would show us the truth. But it turns out it's not critical. In fact, seeing the truth gets in the way of doing what you need to stay alive. And I think a good example is the desktop interface on your computer. And that's what I think evolution has actually done for us. I think that our perceptions of space and time are like the desktop of a computer interface, and physical objects are like icons on that desktop. And that's what evolution has really done for us. It's given us a user interface. And the reason is, for example, if you're writing an email to a friend, and the icon for that email is blue and rectangular and in the middle of your screen, does that mean that the file in the computer is blue and rectangular and in the middle of the computer? Of course not. Anybody who thought that just doesn't understand what an interface is about. It's not there to show you the transistors and voltages and magnetic fields. It's there to hide all that stuff. If you had to toggle voltages to craft an email, your friends would never hear from you. Right? The truth in that example gets in the way. If you had to face the truth, you couldn't do what you needed to do. It's too
You're saying the
complicated.
truth is to actually understand the underlying
Reality.
networking.
That's right.
The underlying reality.
That's right. Yeah, by the way, I'm just using the computer as an example and transistors as the, quote, metaphorical truth in that example. I'm not saying that that's the exact reality. Once you get the metaphor, you can throw that away, right? But whatever the reality is, evolution doesn't need to show us that reality. It needs to give us eye candy. It needs to give us a user interface that lets you do what you need to do and ignore and control reality. Of course, we have to control objective reality, but you can control it even if you're completely ignorant about what it is, like we do every day with our computers. We control all those transistors and voltages, and almost all of us are completely ignorant about what we're really controlling. That's what evolution has done. It's explicitly shaped our perceptions not to show us the truth, because that would get in the way.
Okay. So I want to step back a little bit and ask how each of you ended up in this particular line of work that you do, because you both have these very distinctive ways of looking at the world. So just kind of walk me through a little bit of your personal history and how, for instance, Suzanne, how did you end up becoming a neurologist who studies imaginary illnesses?
Well, I mean, I'd love to say that it was an amazing story. I studied medicine because I went to a school that didn't have a lot of imagination, and you sort of, if you did well in school, you those were sort of things you did. And but I'm really pleased with the choice, because I've discovered that it opens up this incredible world to you. Neurology seemed to be the really obvious thing to me as soon as I encountered it, because there is nothing as amazing as the stuff that happens when this goes right and the stuff that happens when this goes wrong. You know, it seemed to me that other organs of the body had a much more limited range of ways to behave, whereas the brain just seemed of infinite interest to me. And I thought when I chose it, as I've said before, that I was choosing to look after people with these quite straightforward, in a sense, diseases. So pathological processes of the brain or the nervous system or the muscles. And it wasn't until I was a consultant that I realized that was only the smallest part of what I was seeing. Now, I'd been a trainee neurologist for many years. I was extensively well trained. And yet it wasn't until I became a consultant that I took an interest in psychosomatic disorders or physical disabilities that have more psychological cause. And the reason it had escaped me for so many years is because we break down medicine now in this way, where we say, well, you're a neurologist, so if you can't find a brain disease, well, then that person isn't your responsibility, and so on. So it's quite easy now as a doctor to become very focused on one organ and ignore everything else. But once I became a consultant, I realized how frequent seizures, paralysis, headaches, memory loss, all sorts of different sort of symptoms that are psychologically caused are sort of passing us by, even though they are extremely serious, even though they're extremely prevalent. There aren't a great deal of specialists who look after people with these problems. What we do as doctors now is we say, well, your brain scan is normal, so you can go away, or, I can't find anything wrong with you.
Even if the patient is clearly having problems, in other words, if the doctor if you can't find it on the machine that says, oh, here's the cause, You just
Well,
kind of throw up your hands
I
in
think
despair?
what can happen is you say, well, you're not my responsibility so much, not so much as you're not, there's nothing wrong with you, but, if I can't find a brain disease, then I suggest you go to another specialist because I can't find what I'm supposed to find, which makes a particular proportion of patients very easily pass between different people without ever getting a satisfactory answer. I'm speaking as a neurologist, but these sort of symptoms occur in all specialties. So people who feel they can't breathe and have shortness of breath, there's nothing wrong with their lungs. This is more psychologically driven. Pains in your chest, pains in your joints, everything. Every specialty is represented in this. I discovered when I became a consultant that if I didn't take more of an interest in this, I would spend a considerable amount of my time telling people that their scans were normal and sending them away. So I chose to take an interest in it. And now I find it so, but endlessly fascinating. But also imagine yourself in a situation where you're having seizures and a neurologist tells you don't have epilepsy and that your scans are all fine and therefore you can go back to some other doctor to solve it. It is the ultimate dismissal, and I think that structure of medicine needs to change.
Don, let me turn to you. How did you end up doing what you do now?
I was a pretty geeky teenager, and I was very interested in the question, are we just machines? Are people just machines? I was learning a little computer programming and getting the idea that was pretty powerful. You could do a lot there. And my father was a minister, a fundamentalist Christian minister, and so I got a different story on the weekends than I got when I was doing technical stuff during the week. And so, as a teenager, you don't know, you're just listening to the authorities. And so I decided I was very interested to try to understand that question. Are we just machines? And I realized that to really understand that, I would have to do some hard work. And so I ended up working in the artificial intelligence laboratory at MIT, working with a guy named David Marr on vision problems, trying to actually build working vision systems. I figured I needed to take on some really concrete problem and solve it so that you really understand what's going on. Pretty soon my bigger question was the question of consciousness. How is consciousness related to the activity in our brains? Is it fundamental? Are our brains fundamental? Does it give rise to consciousness? And that's an exceedingly hard problem. In fact, it's called the hard problem of consciousness. And I sort of understood that it would be foolish to try to take that on without really having gotten a lot of tools, learning a lot of tools. So I spent quite a few years just working on specific problems in computational vision and publishing papers about how vision does this and that, so I could really start to understand the neuroscience and so forth. And then I started to back away from that and say, okay, at some point you can't just be building up to it. You have to do it, otherwise you'll get too old to do it. So then in the last 20 years, I've been really trying to focus now on how is consciousness related to brain activity and trying to make some progress on that.
So are we just machines?
Great question. The answer is I don't know, but the theory that I'm pursuing right now says the answer is no. So I'm pursuing a theory that says that consciousness itself is fundamental to reality.
So explain, how do you even go about answering that question of whether we're a machine or not?
Well, so there's a field within computer science. It's called automata theory, and something called a Turing machine. And it's a whole formal area so when we talk about what do we mean by a machine or are we machines, it's actually a technical question. Are we just so-called Turing machines or equivalent to Turing machines?
Are we basically just being programmed by our brains? Is that
right.
Really the question?
That's part of the question. It's can we explain everything that we are with unconscious physical systems that just implement circuits that could do Turing machine computations? That would be the technical way of putting out the question. And in some sense, to explain human intelligence, problem solving, attention, memory, and so forth, Turing machine theories turn out to be, as far as we can tell, perfectly fine. There's no hard problem there. We have nice technical problems, but to give computational models of attention, memory, learning, problem solving, intelligence, no problem. The real problem comes in the simplest parts of our everyday life: smelling coffee, feeling the velvet, hearing, a trumpet, those raw sensations, we have no idea how to give a Turing, a machine theory that can start with just machines and give us what these conscious experiences are. No one has any clue how to do that. So the things that you would have thought were hard, like intelligence and so forth, turn out to be nice technical problems, and we're working on them, but they're not mysteries. Just smelling coffee is a mystery. And right now we have no computing machine theories that can start with just unconscious ingredients that compute and give us the smell of coffee as an experience. So that is a showstopper for the field. It's not only do we not have any theories, no scientific theories, and that's a weird thing. We have no scientific theory that can say for any particular sensation, like the smell of coffee, that this is the kind of activity in the brain that is required to cause or is that experience of the smell of coffee. And here's the principled understanding about why that brain activity is the smell of coffee. We have nothing close to that. In fact, we have no remotely plausible ideas. It's not just that we don't have any theories. There is nothing intelligent that we can say about that right now. There's nothing on the table. That's why we call it the hard problem of consciousness. The quote-unquote theories that are out there are believed by the person who proposes the theory and their graduate students. And that's about it.
You've just confirmed for me what I always think. I'm going to be unnecessarily flippant, which is stop trying to create AI machines to be doctors and fly airplanes, and get one that cleans the bathroom and does the ironing. Then you'll actually impress me.
Right. The stuff that we think is really easy, the common sense, everyday stuff, turns out to be really sophisticated. And stuff like playing chess and doing, solving certain math problems turns out to be relatively easy for the computers, even though it's hard for us.
So, Suzanne, does this kind of this question that I guess what's often called the mind-body problem, it's sort of trying to reconcile, what's happening in the brain and sort of, how does that connect to, the mind? Do you think about that kind of stuff in what you do in your clinical practice in neurology?
Yeah, I suppose I do think about it, but I think about it with frustration, if anything, because I think that, again, it's sort of we're desperately trying to map this kind of connectome, understand how everything connects to everything else. But it's, what we have is a lot of people whose brains aren't working, and to extrapolate from that sort of how we do normal things to how we manage a situation when it isn't working just seems like there's miles between those two things. So I think that neuroscience, it's just been unbelievably exciting in the last 20, 30 years. But I'm at the coalface, and I sort of feel slightly, and I think that's why I'm a bit more pessimistic, is I'm at the coalface, and these things are all really fascinating. And I think that people sometimes get the impression that, well, now I can go to my doctor, and my doctor will do an MRI scan, and then they'll know what's wrong with me. But it's just so not like that. And I guess I think it's clearly very exciting. But I personally, for my patients, aren't feeling the benefit of it yet. So I suppose I feel a bit pessimistic in that sense.
But I guess the larger question is there a biological substrate to everything that happens in the mind, to those brain disorders that you are dealing with? I mean, if we were sophisticated enough, if we can drill down far enough, are we going to be able to find the underlying physical cause? I
believe that we can, and I believe there is a biological substrate for consciousness. I don't want to get into talking about consciousness because I'm terrified of what mistake I'll make, but basically I do believe these things all have a biological substrate, and I think we're already at the point where we can start demonstrating biological differences in the brains. So I've been talking about people who have things like paralysis, for example. Their legs, there should be no reason that they can't move their legs. The pathways are intact. You can demonstrate that they're intact, but their perception is that they cannot move their legs, and that becomes a reality. What we can do now with some of these sort of more high-tech investigations is we can show differences in the ways that these people's brains are connected than people who are perfectly well, or, very importantly, people who are pretending to be paralyzed. Because if we're talking about reality, the big problem for my patients is that people believe that if I say that everything is working fine and you can move your legs, and you tell me you can't move your legs, that's because you're not really paralyzed. What we can do now is quite clearly show that there's some substrate in the brain that shows increased connectivity between the emotional part of the brain and, say, the movement part of the brain in people who have these sort of psychosomatic paralysis problems. It doesn't prove anything at this point. It shows the difference. It shows that there is a substrate, that there's something happening differently in people's brains who have these disorders.
Can you explain that? So why would sort of this emotional part of the brain, this emotional response, trigger this feeling that you are paralyzed?
Well, I think, why wouldn't it? Because, I don't want to get Freudian because that's not my take on it, but I still have to think there's some quite interesting quotes in Studies in Hysteria where this was discussed. And in Studies in Hysteria, they say, if an idea can trigger a movement, then why shouldn't an idea prevent a movement? I haven't quoted that exactly correctly. But yes, if an idea is what makes you move, then why is it not possible that if you believe you can't move, that you can't move? We've all stood on the edge of a diving board or something equivalent and tried to force ourselves to jump and found ourselves paralyzed and unable to do so. If you start thinking now about walking, we walk automatically. Movements are automatic. And we don't think about them at all. The minute you start thinking about them, they change. Nothing was as bad for my tennis swing than when someone tried to change my grip.
Right.
Suddenly my arm, I'm aware of everywhere it is in space. And, so the fact that an idea can change your movements or even stop you moving, I don't think that's unusual at all. It's unusual, obviously, for it to get to the extreme that you can't move at all, but not as unusual as you would think.
But it's so interesting because, our operating assumption is that the brain is what generates our mental experience, right? And you're saying it works the other way, too.
Well, the problem is that the brain cannot be trusted. That's the thing. We do not have control over everything, as much control over everything that's happening in here as we think we do. There's much more kind of top-down processing happening than, 50 years ago or mid-20th century. We thought everything was just, we're recording like a video recorder or taking pictures like a camera. We now know that's completely wrong. Things are coming in and then they're being processed from up here so that we're constantly altering our experience of the world. And we're all doing that slightly differently. So I think that's what people kind of don't realize, how much impact I have on my experience of the world. But the minute you start thinking about it, it's so obvious. If you're in a room and your sort of ex-boyfriend comes in with his new girlfriend over there, that's all you can hear. No one else can hear that because that's not the thing that's interesting them. So I think physiologically, there's examples of these sort of ways that we're altering our own experience of the world are around us all the time. And we only become aware of them when we really think about them.
So Don, from a scientist's perspective, how do you put that in your model? This idea that the mind can actually have all these physical manifestations.
Well, I agree with Suzanne that we have found a lot of so-called top-down influences, that you're building models. In the case of visual perception, for example, you're not just simply taking a picture of what's out there. You're actually building models and you're using the data that's coming in through your senses to refine your models. But in neural terms, the pathways that just feed forward the data from the eyes up to the brain are actually smaller than the top-down feedback pathways. They're even bigger. So there's the whole field of predictive coding, where we're making these models, we're predicting what we should see, and then we're just checking against the little data that's coming in. And there's another level of this, though, and that is we do have clean evidence, except in some of the cases you're talking about, that there are clean correlations between neural activity and our conscious experiences. Although in some of these cases you're showing that the neurobiology says one thing and the conscious experience is something else. But there are all these correlations, and in the researchers in my field look at those correlations. We call them the neural correlates of consciousness. We're trying to look for the neural correlates of various kinds of conscious experiences. And there's lots of them, but the old adage, correlation doesn't imply causation, definitely applies here. Just because a bunch of people show up at a bus station and a bus shows up doesn't mean that the people caused the bus to show up there. There was something deeper, namely a bus schedule that caused both to show up there. And so when we have these correlations between brain activity and conscious experiences, we definitely have to, most of my colleagues think that the brain activity causes the conscious experiences. And the reason why I've been looking at this evolutionary stuff and showing that we haven't evolved to see reality as it is because it has an important implication. It means that the very predicates, the very language of space and time and physical objects is the wrong language to describe whatever the true cause and effect of reality might be. It's the wrong language. So we have in everyday life the fiction of causality. It seems like my right hand caused my left hand to move. And that's a useful fiction within our user interface. But it's just a fiction, just like if you drag your icon to the trash can, you might say, well, the movement of the icon to the trash can caused the file to be deleted. And that's fine. That's a nice fiction for the user interface, but it's strictly speaking false. The icon moving on the desktop did nothing. There's no feedback from that into the computer. So we have all these correlations between neural activity and conscious experiences, and I've concluded the reason we can't figure out how brain activity causes conscious experience is because it doesn't.
Doesn't there have to be something that causes conscious experience?
Something deeper has to cause both our experience of the brain and the experience of the other conscious experiences that we have.
What's that something that's deeper?
Well, what I'm working on is an idea that consciousness itself, along the lines you were talking about, that consciousness itself is fundamental. And to make that a scientific theory, I've had to develop, and I've published a couple papers with some colleagues, on a mathematically precise theory of consciousness. And it's mathematically precise not because I think I'm right. I'm probably wrong. But the point is to be absolutely precise so that we can figure out where we're wrong. And that's sort of the spirit of science, is absolute precision in what you're claiming so that you or others can figure out where you're wrong, and that's how you get things going.
So when you say your theory is that consciousness is fundamental, in other words,
Right.
it can't be reduced to something. It can't
That's
be
right.
reduced to, I suppose, the stuff of physics, right?
That's right.
You're
Exactly.
saying it's outside the whole world of
Right.
of matter, of particles. It's something else?
That's right. So it's every scientific theory makes certain assumptions. It says, please, if you're a physicalist, you might say, grant me space and time and neutrons and protons and electrons. And if you grant me that, then I'll explain chemistry and biology and even psychology and consciousness. And what I'm saying is those are the wrong things to start with. Space-time and physical stuff are the wrong starting point. Let's start with conscious experiences, like the taste of chocolate, the smell of garlic, and so forth. Start with consciousness, have a mathematically precise theory of that, and then show from that foundation how space-time and physics comes out as a user interface that certain consciousnesses use as they interact with other consciousnesses. So it's a very different kind of approach. And
Do many people agree with you on this?
Oh, very, very few. No. Yeah. Just my graduate students. Only my graduate students. Well, you might ask, how would physicists think about this? Because surely physics knows that space-time and matter is fundamental, and some cognitive scientist is saying that space-time isn't fundamental. The physicist can come back and just, put me in line. Well, it turns out that physicists, for example, Nima Arkani-Hamed at the Institute for Advanced Study at Princeton, Ed Witten, who won the Fields Medal, David Gross, who won the Nobel Prize, these guys are all saying this phrase, space-time is doomed.
What does that even mean?
It's pretty profound. What they're realizing is that in the attempts to get general relativity and quantum field theory to come together into a unified quantum gravity, they're going to have to let go of space-time. What we thought was the foundation. We all think of space-time as the stage on which the drama of life plays out. I mean,
Wasn't that Einstein's great discovery?
That was his feeling, and he assumed that space-time was fundamental, and he had the space-time loaf and so forth. And so the stage has been there for almost 14 billion years, and life wasn't even on that stage for who knows how many hundreds of millions of years, and consciousness didn't get on the stage until much, much later. That's the standard story. And now we're realizing that space-time has to be emergent from something deeper. It cannot be fundamental. We just can't. So this is from the physicists, like, again, Nima Arkani Hamed. And they don't know what's more fundamental. Seth Lloyd at MIT has proposed that maybe quantum bits and quantum gates. So not in space and time. These are now bits and gates in outer space, but not in space. And each of those gates, its action gives you a little bit of space-time, and the curvature of the space-time is proportional to the action. Anyway, they're trying to start with something that's not physical, it's abstract, and then show how you can get space-time emerging from it. I'm up to the same thing. I'm saying let's get a mathematical model of consciousness on its own terms, not inside space and time, but rather as the author of space and time.
Well, you're saying consciousness precedes space-time.
That's right. Consciousness precedes space-time. It's not, so the space-time that you're perceiving right now is not a stage that you're in. It's a data structure that you're creating right now. You create space and time. You create all the stuff that you're seeing. When you close your eyes, you make it go away.
Okay, you're kind of blowing my mind here.
Yeah, right.
So
Right.
Are you saying consciousness was there before the Big Bang?
Yes. This is a big one. That's right. Yeah, I'm sober. I'm saying consciousness is fundamental in that deep sense, and to make this thing work out, what I have is, so the idea is that the ultimate reality then is a big, vast social network of what I call conscious agents. So we have an infinite network of interacting conscious agents, like I'm interacting with you. You're conscious agents. We're interacting. We're having a discussion. I'm saying that's this huge social network is the fundamental reality, and it turns out that's really nasty because dynamics on graphs is really fairly recent math. It's really, really hard math. So that's what we're working on is dynamics on graphs is that. And then if you look at big data right now, like big data for social networks, Facebook, Twitter connections, and so forth, and you try to visualize hundreds of millions of people interacting and so forth, how do you visualize all those social connections? It turns out it's overwhelming. You need visualization tools. That's what evolution gave us. What we call physical world is a visualization tool. Space is a really dumbed down visualization tool, and physical objects are visualization tools that we use to inspect this vast infinite network of social interactions between conscious agents.
But aren't there actual real objects out there independent of our subjective experience of that? I mean, if there's a bus barreling down the street, right. If I step in the middle of the street, it's I'm going to get knocked over. If there's a mosquito buzzing around me, it decides to bite. I mean, are you saying the mosquito's not really there?
Right. I'm saying that the bus exists only when you perceive it. But I have to be very, very careful. Something exists independent of your perceptions, namely this vast social network of conscious agents. But when you interact with that vast social network of conscious agents, what you see is this dumbed down description that we call buses and so forth. So we have to take our perceptions seriously. I don't want to step in front of a bus for the same reason I wouldn't take that little icon on my screen and drag it to the trash can carelessly. Suppose it's a book you've been working on for 3 years. If you drag that to the trash can carelessly, you could lose 3 years of work. So I take that icon very seriously, but I don't take it literally. Same thing with the bus. I take it very, very seriously, but I don't take it literally. And from an evolutionary point of view, this makes sense. Evolution shaped us with symbols designed to keep you alive. You have to take them seriously. They're there to keep you alive. But that doesn't allow us or doesn't entitle us to also take them literally. So we have to take them seriously, but not literally. And that's what evolution has done. So so this whole thing is not the truth. It's a dumbed down graphical interface that allows us to inspect this vast social network, which is the reality. And so for this whole thing to work out as a scientific theory, what I have to show is all the dynamics on the graph of interacting conscious agents, and then show when I project that back into a three-dimensional interface, I get back general relativity, quantum theory, evolution by natural selection. I have to get back all of current physics as the limiting bounding case of this more general dynamics when I project it onto our simple little interface. So our science has been on the interface. We haven't stepped into reality yet.
Okay, so Suzanne, I have to have you.
I'm
not gonna
way
ask,
out of my depth
I'm
here.
not going to ask you to comment on the nature of
I'm
quantum
taking it
physics
on.
here.
I don't mind. I don't have a clue what he's talking about. But this is essentially what my mind finally started thinking about. Which is, okay, so when we're born, our brains basically have a sort of, they're very, very plastic. So, that's why sort of we can learn any language at all that we want when we're born. But if I'm born in Japan, very rapidly our brains lose certain sort of abilities. So you can't say certain phonemes if you hear Japanese all the time because they're not necessary for you. And then it becomes harder to learn Japanese as you get older and so forth. So we're born with these brains that are infinitely plastic and are influenced by our immediate environments. So why then, if I took someone from an island who'd never seen a bus and asked them to draw it, they draw it the same. Why, if these are constructs, why are all the constructs the same?
Well, as members of the same species, we share a very similar interface, and so we're going to do things in a very similar way. But evolution is actually playing with our interface. There are people with synesthesia. So, for example, there was a guy named Michael Watson. Everything that he tasted with his tongue, he felt an object in three-dimensional space with his hands. So mint was tall, cold, smooth columns of glass, and he could feel it. Angostura bitters was a basket of ivy, and he could feel all the leaves, put his hands in the basket, and so forth. For every single taste, he would create a three-dimensional object with a surface texture and a temperature. So he was using physical objects as an abstract data structure for something that doesn't resemble physical objects, namely...
Yes, but that's just that's just how your brain is connected. So, most of us won't have those two bits of brain talking to each other so freely, and people with synesthesia have connections between bits of their brain that associate different sensations. So that's sort of, that's easier to explain. But I recently went on a holiday to a weird place where I saw an animal called a Cusco. I'm probably even calling it the wrong name, but I saw it the same as everyone else there. Now you might say evolution has created us all the same, but it didn't tell me what that animal looked like. I believe that there is a hard, unchanging. I don't trust my brain. I know my memory is not reliable. I know my perceptions of reality aren't reliable, but I trust that certain hard objects are a certain shape. We all see them a bit differently.
So you think
you don't have to have seen a bus,
that bus
and I
really
show it
is
to
a
you
bus.
and ask you to draw it. Right. There must be someone's never seen a bus somewhere. Find them and ask them to draw, show them the bus. They don't know the name of the bus. They don't know what the bus is for. Ask them to draw the bus. I believe they will draw the same bus that I draw.
Right, and I would explain that by saying that we all share roughly the same interface. So we have the same graphical user interface, and because we share the same user interface, whatever the objective reality is, I'm proposing as conscious agents, but whatever it is, we project that reality into to a similar interface, and that's why we all agree. And then what we do is we say, well, because we all agree,
So
therefore we're all seeing the truth.
outside ourselves.
That's right.
Entirely outside ourselves.
It's entirely outside of space and time. Okay. Now, you can ask the physicists about this. Do they actually think that physical objects exist and have specific properties like position, momentum, and spin when they're not observed? And the technical question is to ask, is local realism true? Realism means that these properties like position, momentum, and spin exist even when they're not observed. They have definite values. And locality means that they have influences that propagate no faster than the speed of light. And we have tested whether local realism is true over and over again, and it turns out it's false. So this is independent of whether quantum mechanics and general relativity are right or not. Local realism is false. And something else called non-contextual realism, the idea, do particles have their positions, momentum, and spin, definite values, and do the values they have not depend on how we measure them? That's the non-contextual. And it turns out non-contextual realism, the claim that they have their values and the values are definite and don't depend on how we measure them, that's also false.
Now, I know that most people who study consciousness, neuroscientists, philosophers of mind, think you don't need quantum physics to explain any of this stuff. That's the wrong level of analysis. I mean, what matters is, what's happening at the level of neurons, neurotransmitters, synaptic connections, all of that stuff. The other stuff is irrelevant, basically, to our understanding of consciousness. You obviously disagree, right?
Right. You're right that I would say 99% of my colleagues in this field think that we don't need to look at quantum effects. There's one big exception. Penrose and Hameroff have a theory in which the quantum states of certain microtubules in neurons of the brain are critical to their theory of consciousness.
And most people think that theory
most of my colleagues
they're
dismiss
crackpots.
That.
Well, they're not willing to say Penrose is a crackpot.
Penrose is not
anyway,
a crackpot.
Yeah,
I mean,
right.
Penrose is so much smarter than me. I have no idea how much smarter than me he is. He's brilliant, and Stuart Hameroff is, he's an anesthesiologist, and he's working with Penrose, and I'm glad that they have that theory. I mean, but I don't think it's true. But the rest of my colleagues who are just looking at the classical physics of neural activity, of course, they can't explain this hard problem of consciousness. So they're dismissing quantum effects, but they don't have a theory that works. So I mean, all bets are off. From the physicist's point of view, the idea that there's a distinction between the classical world and the quantum world, which was so-called part of the Copenhagen interpretation, that's really fallen into disfavor recently. What physicists are now finding is that they can get quantum effects from billions of atoms. So these are we're getting almost like visible stuff here. You can look through, they're almost at the size of blood cells and so forth. You can get quantum superpositions and so forth. And it seems like it's just we haven't been clever enough to figure out how to show this stuff on macroscopic levels. In other words, the real physics from the physics point of view is quantum physics, and the idea of classical mechanics being something separate from that was an old Copenhagen interpretation, which I think not too many people hold anymore.
So I want to come back to the question that's at hand here. What is real? What is reality? If so much of how we perceive is not real, is a fiction, Suzanne, how do you start to answer that question? What is real?
I think that it's not about necessarily on a day-to-day basis saying what is real. It's being aware that not everything is real is a very mentally healthy place to be, basically. Is that you can't completely trust yourself and you can't completely trust your perceptions. And I think once you kind of realize that, but even for your mental health, all of the things we believe about our interactions and our relationships and everything that's happening around us, if we could appreciate that that's a sort of fluctuating thing, that it isn't completely trustworthy, I find that very, very comforting, I'd have to say.
Is reality overrated?
I think you're just generally better to be a little bit skeptical about what's going on around you, because I think a lot of people put a great deal of trust in paying attention to certain physical sensations, or paying attention to believing that their point of view is right, and being aware that their point of view is actually subject to all this processing that's out of their control is actually quite a nice thought. And you think, okay, maybe I'm wrong about that.
Right.
Don, should we care that much about what is real?
I care about it a whole lot. And I can understand people who would rather not, but I think everybody has their own thing.
Maybe my fictional universe is actually kind of a nice place to be.
Yeah, it could be very comforting. I'm an admitted geek, and so that's why I'm interested in it. But I think that reality, the position on reality is maybe seen by a concrete example. If you look at your face in the mirror, all you see is skin, hair, and eyes. But you know firsthand that what you can't see, your love of music, your hopes, your fears, your aspirations, all of your conscious experiences, that huge, rich world that's the real you can't see that. It's hidden behind this simple interface symbol that we call a face. When I see your face and you smile, I can infer that in that rich conscious realm, you're possibly happy. But that happiness as an experience does not resemble a smile. There's just no resemblance. Smiles and happiness are two utterly different things. When I look at my cat, my interface gives me less information about the conscious. I know if it doesn't like this cat food or not, if I've petted it too much. I believe that there really is a consciousness I'm interacting with, and all I can see is this furry, cute face.
Whereas my dog is pretty transparent.
Pretty transparent. That's right. That's right. That's right. And we get down to a rat, it's even worse. And an ant. Now my interface has given me very little insight, but for all I know, the consciousness I'm interacting with there is very, very rich. But in some sense, my interface has to give up. I have a finite number of resources in my interface. This is an infinite realm of consciousness out there, so I have to do things like simplify. And so I simplify, and then I simplify things to the point where I see nothing conscious there at all, and then I say that's the fundamental reality. So what we do is we mistake the limits of our interface for an insight into the fundamental nature of reality. That's a fundamental mistake we mistake. So the idea is that the reality is our conscious experiences. When you look at yourself in the mirror, you see the interface and the consciousness behind. I'm saying that it's true everywhere. Every physical symbol there's a consciousness behind. It's not that your face is conscious, right? Your face is your face. The consciousness is just being pointed to by that face.
So I'm curious about how these ideas apply to your own lives, your day-to-day lives, if you step away from what you do professionally. And I don't know if you think about these kinds of things just as you go about normal business. But Suzanne, do you have any takeaways just from how you apply this to how you go about,
very much just a repetition of what I have said, which is that it's quite useful to know that, when you're, creating memories, that they're fluid and they're changing, and every time you remember them, they're changing again. And what you're seeing is just your version of what you're seeing, and that you have much more influence on that. And I find all of that just really makes me feel better to think about it. It just makes me feel better to know that there's no point in torturing myself with the the reality I'm faced with.
Wouldn't it make you feel worse that you have such a lousy memory?
No, basically, it makes me feel like I have a chance to positively influence it. You are what you believe you are, and I actually have a chance. I don't believe in the reality around us, I think, any more than you, although I have a different take on it. And when I see people whose physical well-being is directly, they have serious disabilities that are a direct result of the way they perceive changes in their body and the way they think about their bodies and the way they react to changes in their bodies, it's really devastating. And then I've got to remember that, if you can influence your general well-being in that way for the negative, then perhaps, I'm not saying that we're all going to get sick, bad things are going to happen, but I like the fact that I have this influence, and I also like to then disbelieve things that don't suit me.
So in other words, if we believe the world is a sunny place and that I have a happy life, we're more likely
much like
to
Don, I'd still
be
take
happy.
I'd still take my coat with me in the winter. Right. I'll believe Don when he steps out in front of the bus, but not until then.
So Don, what about you? Does any of this have any practical value to you in terms of what you do day to day?
I think it does. It's taken a while. It hasn't changed my perceptions until recently, but there's another aspect of that in terms of the idea that we're consciousnesses. It turns out that there's split brain operations that have been done on some people, where you have two hemispheres, and with a knife they can cut the corpus callosum to help with epilepsy and so forth. And it turns out you can do experiments that show that the contents of consciousness associated with the left hemisphere can be utterly different from the contents of consciousness for the other hemisphere. And when you do careful experiments with those two different hemispheres, you find they have different personalities. The left hemisphere tends to make up lots of baloney. The right hemisphere doesn't. The left hemisphere tends to be happier. The right hemisphere tends to be less happy. They like different things. And in one case that a friend of mine, V.S. Ramachandran, studied, the left hemisphere believed in God, and the right hemisphere was an atheist. So one thing that this, realizing that it's consciousness all the way down, I'm not just one consciousness, but I'm a whole network of conscious agents interacting, and that those different agents can have different personalities, can begin to explain sort of some of the times when I'm having inner debates about what I want to do, and they could actually have interesting clinical applications to realize we're not just one single conscious agent, that we're a whole network of interacting different conscious agents with their personalities. Could actually lead to a whole new way of thinking about clinical.
But that places your consciousness back in your brain again, which, I've just been convinced it's not, it's over there somewhere.
Right.
But, because, we shut down. You show pictures to two sides of the brain. You can only see one at a time. You can actually train your brain, monks and people who are very good at, what am I trying to think of?
Meditation?
Yes, meditation are able to sort of train their brain so they can use the two sides simultaneously to perceive things. But all of that just places everything back in consciousness is a substrate of my brain, which is where I stand.
Right, and I think it doesn't. So in the following sense, once I have a graphical tool to look at a network, I can use that tool to play with a network. So I actually knew Joe Bogan, the guy that actually did these surgeries. When Joe cut with a knife, what from my point of view he's doing is he's using the tools of his interface to do a surgery on this social network. He's actually dividing the social network into two. The best we can do because of our interface is see it as two different brains, but that's just because we're projecting this back down into our visualization tool. What Joe really did with his knife was to cut a social network in half, and we see that as two separate hemispheres. So once again, I don't think the hemispheres create our conscious experiences. They're just what our species can do to represent that really complicated social network.
My own brain keeps trying to remember the name of that movie with Keanu Reeves and Lawrence Fishburne.
The Matrix.
Yes, The Matrix. Does anyone ever see behind the curtain, or should we be listening to people who believe in an alternative reality because they're the people who are seeing behind the curtain?
Well, I'm offering you the red pill.
So I want to go to our audience in just a minute. But before I do that, Suzanne, you have written 2 books that are just tell these amazing stories of just things that it would be hard to believe that certain people have experiences that, what we would call psychosomatic. Can you just tell us give us a case study?
So just to give you an example of somebody that I met when I was quite a junior doctor and sort of how much I misunderstood her at the time and how much I'm sort of learning to understand better. So this woman was perfectly well before, no particular medical history. She was working in a supermarket and she got some spray cleaner in her eyes. And she got immediate first aid. People washed out her eyes. She went home. Her eyes were very red, very inflamed. She went to bed. She was a little distressed by this incident. And when she woke up the next day, she was completely unable to see. So she had completely lost her sight. Now, medically, that doesn't really make a huge amount of sense in the first instance. But obviously, if someone says they can't see, they can't see. And therefore, you go through the usual range of investigations, which is, testing the integrity of the eyes with different tests, measuring their brain's reaction to visual stimuli and so forth. And what the test said was that her eyes were working absolutely fine and she couldn't see anything. That was her perception rather than this actually being a reality. But what was most troubling for me when I was a junior doctor still kind of learning about these disorders was this concept of how much insight she had into this. She couldn't see, but she could see. And lots of things really sort of worried me in her behavior. So, for example, she's being wheeled down the corridor in a wheelchair. I'm passing her by and she says hello to me by name. Well, and I don't believe my odor is so distinctive that a person can spot me from 10 paces. So she's reacting to me as if she can see me. And the thing that happened, which absolutely blew my mind, was I'd been looking after her for a while. And then when she was going home, she gave me a card and she had drawn the picture on the card herself. And she had drawn, flowers, a tree, and it was perfect. The colors were right. It looked like a picture drawn by a sighted person. I asked her, I said, I did say to her, because I was so kind of shocked at the time, and she said that, she was able to draw by using the feel of the pen on the paper, but it still didn't make any sense. Now, doctors meet those sort of situations quite regularly, and what we struggle with in that is, well, if she said hello to me and if she drew a picture, she must really be able to see. And while I still believe she has a serious problem, you wouldn't be in hospital saying you can't see unless there is something significant wrong with you. I don't necessarily think that the thing that's wrong with her is the thing I think that she thinks that's wrong with her. And that would be this is not an unusual scenario, people who experience being unable to see when they're in fact able to see. And these are things that neurologists, we have a great deal of difficulty explaining. I'd love if Don could provide me with an explanation, but we tend to kind of consider them as potentially exaggerations of physiological mechanisms that are there filtering out these things that are changing our reality, can sometimes go so wrong that they change our reality way too much. And I see these kind of people very, very often now. And I've come to realize that I've misunderstood everything from the start. That the reason she was able to say hello to me in the corridor and the reason she was able to draw those pictures is because there is an absolute dissociation, an absolute split between her ability to see and her knowledge of how much she can see. So if, let's say, for example, you were deciding you're going to sue the supermarket and you're going to pretend you went blind because of an accident, you would walk around bumping into things with your white stick, bashing it on the floor. This woman had a massive separation between what she could actually do and her experience of what she could actually do. So I continue to see people with these sort of disorders, and many of whom have seizures and paralysis and so forth. And I've come to realize that sort of they are absolutely profound and they're absolutely real. Even though sometimes they are very, very difficult to explain. And in many ways, we tend to judge disease in a way that's become very frustrating to me, which is that, we stratify diseases. Cancer is the worst disease, and this is the not so bad disease to get. And on that kind of way of stratifying diseases, someone who's blind but has completely normal tests comes quite low down on the, list of how serious things are. Whereas I would say if you can't see, you can't see. And therefore that is a pretty serious problem. We need to start taking these kind of problems significantly more seriously than we do.
Okay, with that note of mystery, let us go to the audience here.
Right. So the goal is to have a falsifiable theory, and a couple of the predictions that this whole approach make are quite strong. If any physical object has a definite value of any of its physical parameters when it's not observed, I'm wrong. I'm false. If any physical object like a proton has a definite value of any physical dynamical property like position or momentum when it's not observed, then I'm wrong. So if we can show definitely that any physical object has a definite value of a physical property when it's not observed, I'm wrong. If we can show that anything within space and time has genuine causal properties, I'm wrong. So those are two clear predictions that fall out of this that are falsifiable. But further, I have to give I'm working on a mathematical model of consciousness. I have to have a precise dynamics. I'm working on what the precise dynamics is, and a precise mapping that gives back space-time. And I have to show that I get general relativity and quantum field theory, and hopefully their union. So there's a lot of precise work that has to be done with this stuff. So there are falsifiable predictions right now, and then there's a lot of work ahead to make even deeper falsifiable predictions. Right?
And my response to that is that all?
Then we'll have lunch.
I consider hallucination to be something that one sees that isn't really there. It's hard to say. So I see, for example, our brain can create hallucinations. I would see a lot of patients with epilepsy, for example. So that's when your brain kind of fires autonomously outside of your control. And if you get a big burst of electrical activity in a part of your brain that controls certain aspects of vision, etc., then you will see very faithfully things that aren't there. So I believe that hallucinations are manifested by reactivating connections in the brain that produce this feeling that you are seeing something or smelling something or hearing something that isn't there. I'm not sure that certainly explains hallucinations in the electrical sense in people with epilepsy. I don't know that I fully understand how all hallucinations are generated, or rather, I'm 100% sure I don't fully understand how all hallucinations are generated. But you think that perhaps someone's flicking a switch over in the interface?
Right. I
might have misunderstood some of what you said.
Well, but that actually brings up a really important point, because I'm saying that nothing that we see is accurate to objective reality, so that this is all just an interface. And so, but there is a useful distinction to be made between things that we call illusory or hallucinations and things that we call real. I mean, we are putting our finger on an important distinction there. So what am I going to say about that when I'm saying that all of this is just our interface, is not faithful to the true reality? And from an evolutionary point of view, I think that there's an easy switch to make. Instead of saying our perceptions that are illusory are ones that aren't true to the world, I'll just say perceptions that are illusory are the ones that do not guide adaptive behavior. Right? That's the evolutionary point of view. It's, does this perception guide adaptive behavior? When I am on a drug that makes me think I can fly, and I jump out a window, that turns out not to be adaptive. Whereas when I'm sober and I realize I can't fly, that is adaptive. When I see what we call a Necker cube, this is a line drawing on a flat sheet of paper that when you look at it, you see a cube floating out of the paper. I'd call that illusory because it's suggesting that you could grab and do certain things with a three-dimensional object, and when you try to do that, it doesn't happen, so it doesn't guide adaptive behavior. So if we just, instead of talking hallucinations and illusions being about truth or not, talk about them being adaptive or not, then we get actually what we evolved for, and we get a nice theory. I think that this approach, where I'm saying reality is this vast network of interacting conscious agents, and it's not space and time, it does break down a barrier that has been there between science and religion in terms of things that people in religious fields have been talking about. I'm saying we could actually get mathematically rigorous models of what we mean by consciousnesses. Even, it turns out in this theory, when conscious agents interact, they create new, more complicated consciousnesses. And so you can take very simple consciousnesses, have them interact, and mathematically new, more complicated consciousnesses emerge, and this can go up to infinity. That means I have a mathematical model in which I can actually talk with precision about infinite conscious agents. When we're talking about infinite consciousnesses, now we're talking about the kinds of things that some spiritual traditions are interested in. But for the first time, I can actually have mathematical precision on this. So what I would
infinite consciousness. I mean, another word for God, right?
For in some traditions it would be. But I can now have theorems and proofs about God. And by the way, I'm not saying that my theory of God is right. It's just the first precise theory we've ever had. So, and that's the point. Of course, I'm probably wrong, but the goal is to be absolutely precise so we can now launch a science, the science of infinite consciousnesses, and start to study their properties. How many of them are there? Are they omniscient? Are they omnipotent? Are they omnipresent? These are not things we have to wave our hands about. We can prove theorems. And then we can actually, as we do that, study this and then find out maybe where my theory is wrong and then fix it. So the goal is to take these questions, which are the deepest and most important to us. Who are we? Why are we here? What happens after we die? All these things that are very, very important to us. We've been struggling with these for thousands of years, and we haven't made much progress, partly because we haven't been able to figure out how to turn these into precise theories that we can then try to falsify. And that's the whole point, is to get theories that finally are good enough to be wrong. That's what we want. So that's what I'm hoping to have a kind of spirituality where we can actually be wrong and make false predictions so we can figure it out and fix it and then move on. So first I would say that it's only as a figure of speech that I would say that we're using the brain as a tool, that the brain is just our visualization. that the brain actually has no causal powers. So it's not like, for example, some people think that the brain is a receiver for consciousness, so that the brain, maybe doesn't cause consciousness, but it's a receiver for consciousness. But that's giving the brain some independent existence and some real causal abilities. And I'm not saying that's the case. But the idea then is that if there are this infinite network of conscious agents, we have to study how they interact in various ways. Some of them we see as microbiomes. We see those agents, we represent them as what we call the microbiome within our interface. So what's going to be required is a far more sophisticated biology and neuroscience. Right now we look inside brains, we see neurons and synapses, we say, oh, that means there's neurons and synapses. Now, I'm saying, no, okay, that's what we're seeing in our interface. We have to figure out what that is really referring to in this vast social network of conscious agents. We have to reverse engineer our interface and figure out what. So there's lots of job security for neuroscience in this. I've just opened up, if this is right, we have a lot of job security for neurosciences, and then also for biologists trying to understand the microbiome, because we have to go backwards from the interface to what this is saying in terms of this network of social agents, and then figure out what that interaction is.
I'm very interested in the psychology of your career, to be honest. Well, it's so easy to be a doctor. You know what you're going to do at the end of the day, and you know what you have to solve. And, you've got, you can do it in a reasonable space of time. But you're facing a career where, possibly you will just, after many, many years, say, well, that's wrong, but that's good. So now I know one wrong thing. And then many, many years later, another wrong thing. I would struggle with that. I think I need my rewards to be a bit more instant.
Right. Well, that is the case with all of our sciences. None of our theories are right. I don't believe a single scientific theory is correct. And I think that the most advanced scientists in general relativity, they would say, no, general relativity, it's beautiful, you should study it. There's something deeper. Quantum field theory, it's beautiful, great insights, you should study it. It's not quite right. There's something deeper. Evolution by natural selection, it's beautiful, it's deep, it's the best tool we've got, we should study it, we should use it. There's probably something deeper. And I think every scientist who's at the forefront of their field and really thinking about it would say, yes, our scientists, our theories are the best tools that humanity has ever come up so far, and they're still not there yet. We're not there. And there's a humility that comes with this whole approach. The humility is be precise so that we can figure out where we're wrong and be willing to be shown wrong. And then to realize that probably we haven't yet got a true theory. Yet. It seems to be that there are communications happening between conscious agents. So part of the dynamics that we're going to have to be studying is how agents actually interact with each other and how they learn to communicate with each other. And so part of it may be the conscious agents within you talking back and forth. When we cut the corpus callosum, two hemispheres that used to be an intimate connection no longer can talk back and forth, and you get different kinds of behaviors that come out of that. So that's one aspect of it. And I would say another aspect, the evolutionary arguments that I gave that say that we don't see reality as it is, turn out not to apply to logic and reason, aspects of thought. The arguments that I have published that actually prove with my colleague Chetan Prakash and others that selection pressures are uniformly against seeing the truth it turns out that they do not apply to logic and reason, to thought. The selection pressures are actually not to make us geniuses. Most of us aren't geniuses at logic and reason, but from a fitness point of view, someone who doesn't recognize that 2 bites of an apple give you roughly twice the fitness payoffs of 1 bite of an apple isn't going to survive very long. So you have to be able to reason about fitness payoffs, not about truth. And so our thinking can be more or less accurate. It can be more or less a useful tool, even though our perceptions, in some sense, are an interface that hides the truth. But there's a lot more to be. I mean, you put your finger on a big research project.
I don't work with those things specifically, but yes, I think that these are all related things. If we come back to hallucinations, I mean, some people believe that hallucinations are I was talking about hallucinations that happen as a positive phenomenon in epilepsy, but if you think of hallucinations, as a result of electrical activity, if you think of them more in something like schizophrenia, that this is all, again, about this sort of filtering, is that we learn to recognize our own voice as our own voice. And that if that all starts going wrong, then suddenly our own voice becomes somebody else's voice. And that's how people can potentially believe that they're hallucinating and hearing voices. They're actually hearing their own voice, but that this sort of mechanism of altered perception in the brain that allows us make sense of, to live with the world that we live in, has changed in some way. I think all of these different malfunctions have different mechanisms. The normal physiology that stops me seeing the world exactly as it is completely different to the physiology that produces mental illness or hallucinations in mental illness. But I think these are all related phenomena. These are tricks that our brains are playing on us. And I guess that's why I find some of it positive. If our brains can play those tricks on us in a negative direction, perhaps we can learn somehow to influence that in a more positive way.
There are many more questions out there. We probably could go for another hour here, but we have no more time. Thank you for being a fabulous audience. Thank you to our speakers. Thank you.